Hey everybody, so in this video we're going to talk about scale diagrams. Now a scale diagram is a smaller version of something. We'll generally do this if something is quite large, but we want to be able to fit it on a page, so an example of that would be a map. Honestly, we're going to have a map of Ireland that's the entire size of Ireland, so we have to scale it down. Everything will still be in roughly the same proportion. If we're doing it right, it should be in exactly the same proportion, but it's all just going to be smaller. So an example of this that I definitely have used in my life is model planes. So here we have a model Spitfire. Some of you might have made these when you were kids, or some kind of similar models. So the ratio here, or the scale, is 1 to 90. So that means that, for example, on a real plane, whatever the length is here, the real plane will be 90 times as big. And whatever the width is of the wings, the real width of the wings in the actual plane will be 90 times as big. Whatever size the propellers are, the real propellers would measure 90 times as long. So if we take a couple of examples then, if on our scaled model, the length of the plane is 12 centimeters long, then the real thing, the plane, should be 90 times as big as that. So what we're going to do is we're going to multiply 12 centimeters by 90, because the real thing is 90 times as big. So that means that the actual length there would be 1080 centimeters. Let's do the wingspan in green. So if the wingspan is across here and that measures 10 centimeters, then it's going to be the same thing. The actual length of the wingspan will be 90 times as big. So it's going to be 10 centimeters times by 90. So that's going to be 900 centimeters wide. That'll be the width of the actual plane's wingspan. So let's look at another example now where we have to work backwards. So let's say you've been hired to create a model of the Eiffel Tower for a theme park, and they want you to create a scaled model. So it should be all the same proportions, but you're just going to make it smaller. And the scale that they give you is 1 to 15. So that means your model, for every 1 meter in the model, it'd be 15 meters in the real thing. Or for every 15 meters in the real thing, it would be 1 meter for your model. So to figure this out, we did the exact opposite of what we were doing before. So the height, for example, of the Eiffel Tower is 300 meters. So to figure out the height for your model, what we're going to do is get 300, and instead of multiplying it by 15 to make it bigger, we divide it by 15 to make it smaller. So that means the height of your model in the theme park should be 20 meters tall. The base of the Eiffel Tower is 125 meters wide on each side. So for your model, again, it's going to be 15 times smaller. So what we're going to do is, instead of multiplying by 15, we're going to get 125 and divide it by 15 to make it smaller. So that gives us 8.33 meters in width. So your model there is going to be imagine that's the Eiffel Tower, it's not a great drawing. So your model is going to be 20 meters tall, 1/15 of the actual height, and it's going to be 8.33 meters wide. So 1/15 of the actual width.